Alright, so let's go through this question 2. So we are given ln x plus y bracket is equal to tan inverse y over x bracket. We are asked to show this so-called thing. So we are asked to show x squared plus y squared bracket. Then after that bracket, another bracket is 1 plus dy dx, right? Is equal to x plus y bracket x dy dx minus y bracket. Okay, so first thing, of course by one look I know this one is an implicit differentiation. Okay, so let's do the differentiation for the first term and of course the second term. Okay, the first term, ln, we are asked to differentiate ln x plus y. So means whenever you're asked to differentiate ln, so of course maybe let's do a very quick recap. Ln x, if you're asked to do dy dx, right? For ln x, it's actually equal to 1 over x. So what if you are asked to determine d dx, right? Ln x plus y bracket. So this one, you just draw a horizontal line first. So at the bottom, you copy whatever you see here. So means x plus y. Okay, what about at the top? Okay, at the top is the differentiated form of the x plus y. Meaning you differentiate this thing and you also need to differentiate your y. Okay, so of course differentiate x is 1. This one is simple. Plus differentiate y, you'll get dy dx. Remember your implicit differentiation. So dy dx. So of course, maybe I also talk about implicit differentiation. For example, right, if I give you, I want to differentiate y square. So dx, right? So I just do like a differentiation for x like that. So power bring down, power minus 1. But don't forget to add a dy dx here. So that is the meaning of your implicit differentiation. Okay, so of course with this, I already done the differentiation of the ln x plus y bracket. Okay, now it's time to determine what is the differentiated form of tan inverse y over x. So this one, same thing, you refer to MF27. So okay, let's look at the MF27. So apparently tan inverse, so for example, differentiate, maybe I just put here. So differentiate tan inverse x, for example, you will get the form to be 1 over 1 plus x squared. Okay, so of course, if let's just say you want to write the general form, general form is like that. So you put 1 over 1 plus x squared, right? Then here is you just differentiate the x here. So meaning just 1. Okay, so likewise, if I want to differentiate tan inverse d dx, right? Tan inverse, okay, y over x lah, for example. So this will give you 1 over 1 plus, okay, so whatever you see here, right, just put y over x squared. Then of course, sad to say, you need to differentiate y over x. How do I differentiate y over x? So this one, likewise, this one maybe I use a bit of the quotient rule. So okay, maybe I just use the shortcut that I teach you. So for example, right, y x negative 1. I want to differentiate yx negative 1. So this one you use your product rule. Meaning you differentiate the first one, keep the second one. Plus, keep the first one, differentiate the second one. Okay, let's do the product rule together. So for example, differentiate the first one, right? Differentiate y with respect to x. Means you will get dy dx. So of course you keep the second one, x negative 1. Plus, keep the first one, differentiate the second one, meaning you differentiate x negative 1, you need to bring down the negative 1, so this one bring it down, and after that x minus 2, then done already. So that is how you actually differentiate the y over x. Okay, so now what we are required, right, of course you can see the form is already more or less already, so what we need to do is to make it nicer or simplify lah. Okay, so I erase this first. Okay, so of course the left hand side, so I'll get 1 plus dy dx, right, over x plus y is equal to, this part will be 1 over 1 plus, okay, maybe this one I just put y square over x square. Then of course this part will be dy dx x minus 1. The last part will be negative y x minus 2. Okay, let's see. Okay, almost ready. So first, maybe I will need to, okay, the left hand side is like 1 plus dy dx, right? Then this part will be x plus y is equal to 1 over, okay, maybe I just make it nicer for this. x square, I made the same denominator for the bottom, x square over x square, right, plus y square over x square. Then next part will be this. Okay, this maybe I can factorize out. Should I factorize out? Okay, maybe I factorize out x negative 2. So I factorize out x negative 2, right? So what is left for the very first term will be dy dx x to the power of 1. I just put x lah, minus y, and put a bracket, curly bracket, square bracket. Okay, so okay, I want to make this part first. So it's okay, this part, right, will be x square. Okay, so 1 over x square plus y square, the whole thing, right, over x square. So just do the KCF, keep change flip, right, I will get something like this. So eventually I'll get x square over x square plus y square. So now it's much nicer already. Okay, then next you can see apparently you can see that something can be cancelled already. So I put dy dx x minus y. Okay, so this thing multiply with this thing, so it's x to the power of 2 times x to the power of negative 2, right? So it's actually as in 1. So it's 1 x square plus y square. Okay, so this one will be dy dx x minus y, square bracket. Okay, let's see. Okay, so this one will be 1 plus dy dx, and this part will be x plus y. Okay, so let me see the form first. X square. Okay, found the thing. Okay, so let's do the cross multiply. So for example, because apparently I see the thing already. So this one, cross. So you can see, let's take a look at this cross first. So you can see, x square plus y square, the whole thing, right, multiply by this whole thing right here that you see here. So of course 1 plus dy dx. So the left hand side is out already. Okay, now look at the purple color cross, right? So it's equal to so of course x plus y, the whole thing multiply by solve already, I mean show already. So it's x dy dx minus y, and put a square bracket. So with this shown. Yep, so that is how we actually do this. Actually it's simple, just that the manipulation is a bit more complicated, but I think with will and determination you are able to do it.